Alright, this is Math 111 OLC, Winter 2012. We're in Unit 2, going to talk about Section 2.4 today, which is entitled Writing Equations of Lines. Basically what we're going to do is establish a very important form of line equations called slope-intercept form, and I'm going to do that for you right now. It's pretty painless, the derivation of this very powerful tool, so give me a minute to discuss this. Let's say I've got a line. Any line. Let's say any non-vertical or non-horizontal line. I'm going to say it looks something like this. Let's see, and if it's non-vertical, that means it will have some y-intercept somewhere along the y-axis, and I'm going to call the coordinates of that y-intercept 0, b. So the y-intercept of this line we're going to assume is the parameter b. I'm going to claim there is a point, some point somewhere on the line. I'm going to label that point a very general x, y coordinates, right? I can compute the slope of any line given two coordinates of the points on the line, as we know from section 2.3. So if I compute the slope of this line according to my slope formula, it's going to be y2 minus y1 over x2 minus x1, where x2, y2 is the general coordinates xy, and the x1, y1 would play the role of 0, b on this particular line. Of course, I can simplify this expression. X minus 0 in the denominator just turns into an x. And if I solve for y in this expression here, I'm going to multiply both sides by x and then just add b to both sides of the equation. Alright? So this gives me my slope-intercept form, which I'm sure you've seen before in your mathematical careers. Let me write y on the left and the expression mx plus b on the right. This is a very powerful expression of a line equation called slope-intercept form. And namely y equals mx plus b. The power of this form of line equation can easily be seen in that if it's in the form y equals, in other words, if you've got y solved for in a line equation, you can instantly tell me what the slope is by inspection just by looking at the coefficient of x, and you can instantly tell me where the y-intercept is by looking at that constant value here. Right? So this is slope-intercept form of a line, any line with slope equal to m and y-intercept equal to b. It is by far the most used of the line equation forms. I'll give you an example of this. I'll say write equation of line. That's the title of this section. We're going to be writing equations of lots of lines. Write equation of line with slope equal to minus 1 and y-intercept equal to 7. Right? Well, very simple. And if you've got your slope and your y-intercept, all you got to do is plug in the respective m and b values for slope and y-intercept. The slope is minus 1 and the y-intercept is 7. So I could just write down my answer instantly with no algebraic work really needed. Y equals minus x plus 7. That line has a slope of minus 1 and a y-intercept of 7. We can also use this information to graph the line. If I draw a quick graph of this line, that went a little crooked. If I draw a quick graph of this line, well, I can start. I know for sure the y-intercept is 7. 2, 3, 4, 5, 6, 7. Let's say I hit the x-axis right there. And if I know my slope is -1, and I can tell that by the hang on, I'm going to drop something. I can tell that by the x coefficient is -1. That means I'm going to lose 1 unit of rise for every unit of run. With a slope of -1. So we can use the slope-intercept form as a graphing aid also. Erase this extraneous mark here. Alright. How about this? Let's do another example here. Right. Equation of line. You're going to see that phrase a lot here in this section, right? Equation of line with a slope equal to 4 and through the point 5, 9. Well, I can use slope-intercept form to answer this question, but I don't know the y-intercept. Notice this point is not the y-intercept. If it was the y-intercept, the x-coordinate would of course be 0. Alright, well, what do we know? Well, we know we can write a line equation if we know a slope and a y-intercept. Well, here in this line, the line we're asked for here, we know the slope is 4. So I know ultimately my line has got to look something like this. I know in slope-intercept form the x-coefficient will be 4 because that's the slope, and what I don't know is the y-intercept. Well, I can use the fact that 5, 9, the point 5, 9 is on this line. All points on the line must solve the equation that generates it. So what I can do is take these coordinates, 5, 9, plug them in for x and y respectively, and solve for the unknown b value. Alright, so when y is 9 on this line, that means x must be 5, and I can easily solve for b here. Well, 9 equals 5 times 4 is 20 plus b, so b is going to be a -11. My y-intercept is -11. So if I then write my final answer, you're not done yet. You've got to write down a line equation. We were asked to write a line equation. So if I'm asking what is the equation of the line with a slope 4 and through 5, 9, there is my answer. Y equals 4x minus 11. A pretty standard technique used through all of algebradom. Let's try another one. I'm going to ask you to write equation of line with slope equal to -2/3 and through -4, 5. Now be careful here, you're going to have some unpleasant fractions to deal with. Well, not too bad if we remember our fraction arithmetic well. Alright, so that is our task. Hang on, that's a 5 there. Alright, what I'm going to strive for is my answer in slope-intercept form. Again, I already know what my slope has to be, -2/3. Alright, so I know my line equation, my answer to this question must look like this. But again, I don't know the y-intercept. And notice this point given is not the y-intercept. If it was, the x-coordinate would be 0. So what I can do is, again, is plug in the x and y values for this point into my general formula and solve for the unknown y-intercept. This point is on the line, so it must solve this equation. So when y is 5, x is going to be minus 4. Alright, so with a little fraction arithmetic, we should be in good shape. 5 equals, let's see, minus 4 times minus 2/3 is positive 8/3. Alright, so I'm going to have to subtract 8/3 from both sides to solve for b. Well, to get a common denominator, 5 is 15/3. And from that, I'll subtract 8/3. Once I've got a common denominator, I'll just subtract the numerators as indicated, and I'll get a positive 7/3 for b. Alright, you're not done yet. Remember, you have to write down your final answer. So, recall we're just solving for the unknown b value here. So, the complete answer, the equation of the line for which we are requested, is y equals minus 2/3 x plus 7/3. Alright. Let's talk about another similar problem with another wrinkle to it. I think I'm going to need some more room here. Let me get another layer. Alright. And let's see, I'm going to ask us to write an equation of line through, let's say, minus 2 comma 5 and 4 comma minus 3. Alright, so something which would not be very easy if we did not have this slope-intercept form. Well, again, to write an equation, the simplest way to write an equation with a given number of characteristics is to find the slope and find the y-intercept. And if you can do those things, you're essentially done. Well, I can easily compute the slope of the line through these 2 points with my slope formula. y2 minus y1 over x2 minus x1. I'll grind this out. I'll get minus 8 over 6, which of course reduces to a negative 4/3. If I plug that value in for m in my slope-intercept form equation, I then can see I only need to solve for b to be done with this problem. Alright, how am I going to find b? Well, I'm going to need to plug in either of these coordinates. They're both on the line, so they both must solve this equation. So I see no real advantage to picking one pair of coordinates over the other. So I'll pick 4 comma minus 3. When y is minus 3, x then has to be positive 4 on this line. And now I can solve without too much trouble, hopefully, for b. So minus 3 equals, let's see, minus 4/3 times 4 is going to be minus 16/3. I'll add 16/3 to both sides to solve for b. Again, I'm going to need a common denominator. Minus 3 is minus 3 over 1. So I'll multiply top and bottom here by 3 to get a common denominator. I'll get minus 9/3 plus 16/3 equals b. And of course, that reduces to positive 7/3. So my final answer is going to be y equals minus 4/3 x plus 7/3. Alright, let me scroll back up. we were asked to write the equation of a line through those 2 points. Right, so we know the slope is minus 4/3, as we found out here, and we found the unknown y-intercept with a little bit of fraction arithmetic. Okay? Alright. We can also use the slope as a graphing aid. Kind of hinted at that earlier in the lecture here. Use slope intercept form as a graphing aid. And what do I mean by that? Well, let's take an example. Find the slope and y-intercept of this line equation. 2x plus 3y equals minus 9. And I'm going to use this information to graph this line equation. Here's a little bit of an example here. All right. So what I'm going to do to determine the slope and the y-intercept, all I need to do is convert this to slope-intercept form. And to do that, all you really need to do is solve for y. So I'm going to start out with 2x plus 3y equals minus 9. I'm going to convert to the form y equals mx plus b, because then I can easily state or see the slope and y-intercept. So what I'll do here is I'm going to subtract 2x from both sides. Then I'll divide all terms, both sides, by positive 3. The 3's cancel out on the left, so I'll get y equals minus 2/3 x minus 3. Alright, so what I've done is created an equivalent form of the equation I was given, but in an easier to digest form, namely slope-intercept form. Alright, how can I use this information to graph this line? Well, I know the slope is minus 2/3. And I know the y-intercept is minus 3. I claim with these two pieces of information, graphing is an easy task. Let me show you what I mean. And let me graph. We get a little bit of a graph here. Oops. I keep doing that. I don't know. X, Y is the horizontal axis. X is the horizontal axis. Y is the vertical axis. Alright, I know my y-intercept is minus 3. So I'm going to start out my task at the y-intercept, namely at the point 0, negative 3. Right? I know the slope is minus 2/3. That means my ratio of rise to run is going to be minus 2 to 3. That means if I run 3 units, I'm going to fall 2 units. So my run here is positive 3, and my rise, my corresponding rise, will then be negative 2. Right. With that information, I can get another point on the line. The coordinates of this new point, well, if x goes up by 3, the x coordinate will be 3. If y goes down by 2, the y coordinate will be minus 5. And I can connect those 2 points with a line and say I've made quick work using slope-intercept form of graphing this line. 2x plus 3y equals minus 9. 2x plus 3y equals minus 9. And so label the line with the graph that generates it, and with the formula that generates it, and move on to the next problem. Okay? Let's try another one, much like this one. I'm gonna say graph. What happened? Graph 3x minus 2y equals minus 4. Alright, now at this point I suppose it's a matter of taste what you want to do. In section 2.2 what we did is made tables of values, and through trial and error method and a guess and check process we generated a table of 3 pairwise connected values that generated the graph. I claim we can maybe make things a little easier if we convert to the format y equals mx plus b, because then we will know the slope, we will know the y-intercept, and we can use those two pieces of information to graph the line. Makes it a little easier, I think. Alright, so I'm going to start out with 3x minus 2y equals minus 4. I'm going to want to solve for y here. That's what you have to do to convert to slope-intercept form. So let me subtract 3x from both sides, and I'm going to divide all terms, both sides, by negative 2 to isolate y on the left. Alright, minus 3x over minus 2 reduces to 3 halves, positive 3 halves x, and minus 4 over minus 2 is, of course, positive 2. So I've converted from standard form to slope-intercept form. With 2 easy steps, really. So now I know my slope is 3 halves. My y-intercept is 2 because I am in the form y equals mx plus b. Alright, I'm going to use that information to graph this line then. Y-axis is the vertical axis. X-axis is the horizontal axis. I'm going to start my line at the y-intercept of positive 2. Draw it right here. Now my slope is 3 halves. That's my ratio of rise to run. Write that down. So that means if I run 2 units to the right and a positive run is to the right, I will rise a positive 3 units upward. Alright, so let me go ahead and do that. I'm going to run 2 units to the right and then rise a corresponding 3 units to get another point on the line. Alright, so let me say I've got 2 units of run labeled thusly in my slope triangle and a 3 units of positive rise. If the coordinates of this point are 0, 2, then the coordinates of this point must be, well, let's see, x goes up from 0 to 2, y goes up from 2 to 5, right? Y goes up by 3, so that gives me coordinates of another point on the line, and 2 points determine a line, so I can graph the line equation perhaps a lot more simply than generating a trial and error table of values. Let me label the line with the equation that generates it, and another powerful use of slope-intercept form. Alright, I want to talk about now parallel and perpendicular lines. Oh, let me get another layer here. Alright, let's talk about, in this context, writing equations of lines parallel and perpendicular lines. Parallel and perpendicular lines. Alright. Well, we talked about parallel perpendicular lines in section 2.3, as you recall. Let me pose to you a question. Let's say I give you a line equation. And let's say it looks something like this. 2y equals minus 3x plus 12. And let's say I give you another line equation. This line equation is in standard form. 6x plus 4y equals 7. And let me ask you this question. Are these lines parallel? Are these lines perpendicular? Or are these lines neither? A familiar regions type question. Well, it's kind of hard to say. I can't really tell just by looking at these line equations. This one's in standard form. This one is in some obscure type form without a name to it. How am I going to determine if these lines are parallel, perpendicular, or neither? Well, you've got to find the slopes. And once I can find the slopes of these lines, I can make an easy comparison. If the slopes are the same, they're parallel. If the slopes are negative reciprocals, they're perpendicular. And if they're neither, then they're neither. Right? Well, to find the slopes, the easiest way is to convert both equations to the slope-intercept form. Then I can just spot the x coefficient and make an easy conclusion based on that. Let's look at line 1. 2y equals minus 3x plus 12. Well, all I really need to do to convert this to slope-intercept form is divide both sides, all terms, by 2. Right? And the 2's cancel out. On the left, I get y equals minus 3 halves x plus 6. There's 6 there. How about line 2? Well, again, here's line 2 up here. If I want to convert to y equals mx plus b, I'm going to have to solve for y. So let me go ahead and subtract 6x from both sides and divide both sides, all terms, by 4. Right, the 4's cancel out on the left. I get y equals, well, minus 6/4 reduces to, guess what, minus 3 halves. And 7/4 I don't care so much about here. All I really need to do at this point is compare the slopes. Now that I've correctly converted them both to slope-intercept form, I can see that the slopes are the same. And if the slopes are the same, the lines, of course, are parallel. So a little bit of algebra drudgery there, but once you're done, you can easily make a visual inspection of each of the slopes, right? Let's try another one here. Again, I'm going to give you 2 lines. Line sub 1. Line 1, I'll say it's 3x plus 2y equals 6. A line in standard form. Let's say L2. Line 2 is given as 2x minus 3y equals 6. All right, 2 different standard form line equations. All right, again, the standard question here, are these parallel, perpendicular, or neither? And the easy way to do this is to convert to slope-intercept form. So I'm going to work with line 1 first. 2y equals minus 3x plus 6. I'm going to divide all terms, both sides, by 2. I get y equals minus 3 halves x plus 3. And I'm now in slope-intercept form. Let me work on line 2 now. I'm going to, well, let's subtract 2x from both sides. Now again, you want to solve for y to get it in slope-intercept form. So I'm going to divide both sides, all terms, by minus 3. And I get y equals, well, minus 2x over minus 3. That reduces to 2/3 x. And 6 over minus 3 reduces to minus 2. I don't care so much about the y-intercepts for this problem. What I do care about is the slopes. This is the slope of line 1. This is the slope of line 2. And of course, you realize that these are negative reciprocals of each other. Let me write that down. These are negative reciprocal slopes. And when you've got that situation, your lines are perpendicular. So your answer to this question would be perpendicular. The lines are perpendicular. Okay? Alright. One more subtopic I want to talk about, which represents the upper limit of difficulty in this section coming up. Let's again talk about writing equations. It's really what we've done already thus far with a slight new twist to it. I'm going to pose this scenario to you. Again, section 2.4 is all about writing equations. Let's see, write equation of line through minus 2 comma 5 and parallel to the line y equals 8x minus 3. Yeah, let me fix this a little bit here. All right, equation of line through minus 2, 5 and parallel to the equation y equals 8x minus 3. Well, the key word is parallel. You want a line to be parallel. Parallel to what? Parallel to this line. Well, this line is already in slope-intercept form. So you know the slope of this line is 8, because that's the coefficient of x in that form. Alright, so I need my line to have a same slope as this line because they're parallel. Alright, so I need an equation of this form where y equals 8x plus b. Alright, well, I don't know the y-intercept. Well, you don't know the y-intercept, but you do know the line has to go through that point, so I can just substitute those x and y values in my equation. When y is 5, x is minus 2, and with a little detective work, I can solve for b pretty easily. If I add 16 to both sides, I get b is 21. Alright, now I don't stop here. I've got to write down my final answer as a line equation in slope-intercept form. So there is my answer, line equation in slope-intercept form. Y equals 8x plus 21. Alright, I want to do another example from the homework list. This is exercise, I believe it's number 66 on page 173 in your text. You might want to take a look there and pause if you would like, and familiarize yourself with the problem statement, and I'll wait a minute. Alright. Let's see, this one's a little harder. So we are asked to write an equation of a line through a given point, through 1 comma minus 5. Make sure I get this right. And perpendicular to this line, 4x equals minus 3y plus 20. Alright, there is the task at hand in this problem. Alright, well, the first thing we notice here is the word perpendicular. Perpendicular to what? Perpendicular to this line. Alright, so what I'm going to do is find the slope of this line, and then I'll take the negative reciprocal of that to find the slope of this line. The line that we are asked to construct. Alright, how do I find the slope? Well, I'm going to need to convert it to slope-intercept form. That's the easiest way. Well, I've got to solve for y. I'm going to add 3y to both sides. I'm going to subtract 4x from both sides to get the y term on the left. Now I'll divide everything by 3, both sides, all terms, by positive 3. The 3's cancel out. I get y equals minus 4/3 x plus 20/3. Now 20/3 is already reduced, and so is minus 4/3. I'm not so much interested in 20/3 in this particular problem. What I want to know is the slope of this line, minus 4/3. Now, scroll up, we want a perpendicular line to this line. So I need a slope that is the negative reciprocal of minus 4/3, and that's positive 3/4. You take the reciprocal of minus 4/3 and negate it to get a positive 3/4. So I know my line, the line that I need, the line that will answer this question is going to look like this. Y equals 3/4 x plus b. The coordinates we need to go through are 1, minus 5, and I can use those coordinates to solve for b. So when y is minus 5, x has to be 1. Again, we're going to have to do some fraction arithmetic here, not a big deal. Well, minus 5 equals 3/4 times 1 is just 3/4. I will subtract 3/4 from both sides. And let's see, minus 5 is minus 5 over 1. I'll multiply top and bottom by 4 here to get minus 20/4 equivalently. Minus 3/4 equals b. So my y-intercept is, of course, minus 23/4. Alright, so my slope, recall, is positive 3/4, and the y-intercept is negative 23/4. And so there is the equation of the line perpendicular to the given line and through the point 1 minus 5. Here's my final answer. Alright, this concludes the lecture on section 2.4. And again, please be sure to complete all homework problems. Check them all in the PDF files I posted on Angel before you attempt any online exams. That is all.